Hey everybody, this is Alex Merced from alexmercedcoder.com, and this video is sort of a intro understanding of the internet. Like, the idea is just to kind of understand like sort of how things like what HTTP, WebSockets, all these kind of things are. So essentially, with like the creation or advent of the internet, the idea was all you were doing was creating a large network of computers that spanned all over the world. The question is like, how do you communicate across such a network of computers? Because again, like, the more computers that are connected, the farther the distance, the more you want to condense what you're sending because it's going to get there faster. Especially back in the old days, if you remember, like 56K internet connections, which were like, you know, at the time really cool, but now like if we had internet that slow, it would be like a tragedy. Um, So basically, what happened is that they came up with sort of a protocol for sending texts over a network that allowed you to send sort of complex information through very simple text, and it's called the Hypertext Transfer Protocol, or HTTP. So let's talk about that. Let's talk about HTTP. And anytime you see these like standards, they generally like involve certain sort of like conventions and standards that you expect between actors on the network. Okay, and basically, the hypertext transfer protocol is just basically the idea that two computers will send messages to each other. So basically, here we'll have one web server. Okay, and all a web server does is able to hear and send requests. Okay, basically, it's a sender and receiver of requests. Okay, although other things can send requests, like browsers can send requests. Okay, but so it's really more so like you can think of the web server as a receiver request, but they can also send. Cool. But essentially, what happens is when you have a standard HTTP connection between two computers, what happens is one computer, we'll say in this case one web server, or it could be a computer with a browser or whatever. What happens is a connection opens. So basically, we sit there in our request. So in the request cycle, okay, we have a request, and the request has certain headers that specify certain things. So like, we're going to specify like a host, like who are you sending the request to? Okay, so this is all stuff that's just included in this sort of text blotch. Okay, you're gonna have headers, and the headers basically tell you sort of, they're like, it's like metadata regarding like, what is this request? Like, yes, you just sent me a bunch of text, but is there anything I should know about this text? Like, what is the text that you're sending me JSON data? Is it XML data? Is it URL encoded data? Like, what kind of data are you sending me? That might be included in headers. Hey, is there certain things you're sending me, like authorization related? That's all in the headers. Okay, so you send over headers. It's all text, and then there's a body. Okay, kind of like the body of a letter, and this could be where like the data goes. And again, you would refer to the headers to see sort of what type of data is the body, and then you would decode that body on the other end when you receive it. Okay, but at the end of the day, the request itself is just a big blotch of text. Okay, it's just a bunch of text. Okay, just to kind of show you an example, if I were to head over to devnursery.com, okay, Control-Shift-I, okay, there's a section called the Network tab. And here you can kind of see the different requests that your browser is making every time you go to a website. Okay, so you see here, these are all different HTTP requests. So if I click on one, here we're just logo, so it's looking for a logo. So see, that's the request URL, or aka the host. I mean, technically the host is this, but that's the request URL. There's a request method. So on top of that, you're saying like, what kind of request is this? And the server will respond differently depending on like what the request is. So basically, that receiving server, like that thing that's receiving, is going to examine this text message for all these things. Okay, and then basically when it responds, it sends back a status code, which can mean different things. If you're ever wondering like, what do these status codes mean, one good way to kind of get an idea is using HTTP cat and like looking at pictures of cats to see what these different HTTP things are. And there's also a dog version of it. Let me see here, dog, HTTP, dog. There we go, HTTP status dogs. And you can kind of see what like all these different like status codes mean based on dog pictures. So that's always cool. Okay, anyways, So here you have like the IP address, but see, like here's all the headers. So here's like telling you what kind of content it is. So in this case, it's sending over text, HTML, was our request. And essentially, like HTTP is just about sending text that's like encoded in this way. Okay, so you can see all those requests here in the browser. So you can see like every little thing, every little picture, every little thing that this website needs, like this is a font, involves a request to somewhere, and then that somewhere is sending a response. But again, it's a two-step process. A connection is open, a request is sent, and then the web server receives it, and that connection is closed. But then what happens? Oh, no, not here. Okay, what happens is that when the receiver is ready to send back a message, a response, it opens a new connection, so it creates a new HTTP message, and then that comes over here. So it's always constant, like one connection, thing gets to where it's going, connection closes. Open connection, send thing, it gets where it's going, it stops. And the thing is that basically like there's these roads that these things travel over. These are called your IP ports. So you might have seen something like, if you're a developer, which is I assume why you're watching this, you might have seen something on a screen called like localhost 3000 or something like that. Essentially what localhost just means your computer. Okay, a localhost is the same thing as the IP address for the computer that you're on, which is always 127.0.01.1. Okay, so that's localhost. It just means your computer. Okay, so that's all that is. The 3000 is called an IP port, and there's up to like a little over 65,000 of these. Okay, and the reason why there's 65,000 is not because you're going to be sending 65,000 messages all the time, but it's because when they created these things, they store the port number in a 16-bit integer. Okay, and I'm not going to get into like what 16-bit integer means, and what base 2 is and all this. But the basic idea is the more bits a number is, the higher number it can hold. Okay, so this is why it was such a big deal when like video game systems went from like 8-bit to 16-bit. It just means you can store bigger numbers in sort of one unit of information, which means you can do more complex things. Okay, so in a 16-bit integer, the highest number you can store is like 65,553. Let me double check. Okay, max number of IP ports. Okay, close enough. 65,535. Okay, transpose the last two numbers. But I mean, that's the reason why. Like, that's just, so it's not like you're gonna have 65,000 ports. It's just that the number of port is stored in a 16-bit integer, and you can choose any number that could be stored in that 16-bit integer, which could be up to this number. Okay, so a lot of these ports, and all these ports are just basically tunnels on which computers can send messages to each other. So basically, as long as I have the IP address, not 127.0.1, this particular IP address always points to the computer that you're on. But let's say I had your like external public facing IP address, and it was something like 568. Blah 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 blah. No. Blah, 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 blah. Something like that. Okay, just this theory. So let's say that was your IP address, even though that's not well formed, but we'll let it go. Okay, let's say that's your IP address, and then I put this port there. I'm saying, hey, send the message to this computer and send it to them on port this. Okay. And essentially, if your computer is on, my message should get to your computer. And assuming you have some sort of software listening for that message on that port, your computer will do whatever it plans to do with that response, with that message, as long as my computer's internet connected and your computer's internet connected, because we're all connected on the same network. Now, if we had our own like local network, so like if that like a work intranet, you could still send these kind of messages as long as you have the IP address of the computer on that network, and then you send it to the right port. So the point is, all this is saying, hey, connect to this computer, and then this is the port, and again, that port could be up to like 65,000. Okay, just understand what like that means. So what happens is that on the internet, there's a standard as far as like what kind of data goes over which port. So traditional HTTP data, let me just get this out of the way. traditional HTTP data would normally, and it still does, travel over port 80. So if I were to go to http://devnursery.com, it's going to initially send that request over HTTP over port 80. Okay. Now you'll notice it's gonna still like end up sending it, like it'll still have like a little lock there. So see what actually happened is I sent it over port 80, which is unsecure HTTP, hypertext transfer protocol. Again, the word text because we're sending text between computers. But usually the way it's set up, the ending server, like where you're going, like what happens is that request gets sent to first before it gets to like the computer that Dev Nursery is hosted on. It goes to a place called DNS, the domain name service, and the domain name service has settings set up by whoever owns that domain, like how to handle, like, hey, if someone goes to this URL, what IP address, what computer do you send it to? So most of the time what you do is when you have a what usually happens on the actually ending web server, so basically it goes to DNS, it sees that devnursery.com is hosted on, let's say, Netlify. It'll get sent to Netlify's computers, and Netlify's computers, they'll have probably something like Nginx, which is a server, a type of web server that can be used as like a reverse proxy. All that means is that it just stands in the middle so my application's running on like Netlify's computers. Once it gets to Netlify's computers, instead of going directly to my application, it's going to go to something like Nginx or Apache. And then Nginx or Apache are going to have a bunch of settings saying, hey, if someone asks for this website, send them here. If someone asks for this website, send them here. So that request is going to arrive at port 80 to, let's say, Nginx. And then it's going to have a rule saying, hey, this is port 80. Well, redirect it to the secure pipeline. So nowadays when you're doing HTTP, even though HTTP gets sent over port 80, it immediately gets redirected to the HTTPS version, which is on port 443. Okay, and so that's why you never have to write these numbers. Okay, you never have to go like, I don't have to go devnursery.com : 80, because when I write HTTP at the beginning of the URL, or if it assumes that, okay, HTTP// the browser knows HTTP traffic goes over port 80, but let's say theoretically the computer that I had Dev Nursery running on had stuff running on port 5000. I could theoretically do this. Like, I'm not going to get anything because there is no such thing. There's nothing running on port 5000, but theoretically. So it is sending a request to the IP address that devnursery.com is on and trying to send the request to 5000, and it's currently waiting for a response. So some computer did just receive a request on port 5000. It won't know how to handle the request because it's not prepared to handle that request. So I'll just get an error in a second, which I actually don't want to do. Okay. But essentially, like, theoretically that is possible. Okay, so that's like, those are the ports that HTTP traffic. So those ports are kind of like claimed. There's like certain ports that are like standard, like you don't touch because other things are kind of like using them. Cool, so that's HTTP, but the same ports are used for WebSockets, which is a newer protocol. Because computers have gotten better, so newer protocols are being introduced to browsers to do cool things. So there's WebSocket, and then there's WebSocket Secure. And again, all the secure means is just that you have you're encrypting the data. So basically, when the data, since you have a secure certificate, any data that's sent over or received gets encrypted before it leaves your computer and doesn't get de-encrypted until it receives its destination. So this protects it from people who are like trying to grab the information by trying to grab information floating through the sky. So imagine like someone's like driving cross country. Okay, and you know, you're driving from, let's say, like a very safe place to another safe place. But in between, you know, there's like pirates and things like that. Basically HTTPS or anything with the secure and it's encrypted, so it's like driving like an armored truck between versus driving sort of like a Jeep where you're exposed. So, you know, that's why generally everything nowadays is secure. So again, WebSockets work a little bit differently though. Okay, so let's just kind of copy this. I want to copy these. Control C, Control V. Now WebSockets, on the other hand, instead of having like a one-time connection between two spots, when you open a WebSocket connection, it opens a two-way connection that doesn't close. So essentially, the connection is established and it stays open. Okay, and then what happens is you can send messages to each other. And the way the web servers work, so if you ever use something like socket.io in Node or something like that, essentially what it does, it just listens for these events. So basically, this server does something. It's going to send over an event here to this server, and then this server has a listener that's listening for a particular event and says, okay, when this event happens, do something. And then when it does the thing, it sends a new event to here, and that responds. And they just continuously keep responding to events that the other one emits. So instead of here, we're saying, hey, I want to send a message. And then it says, okay, here's a response. And it's just one request at a time, one response at a time. This is just like a bunch of, it's like more like volleyball, where they're volleying events and responding to those events. They're not establishing a new connection for each event. So it just goes back and forth. This is kind of how chat apps are built. Okay, so this is how chat apps work. That's why you're able to notice when people are typing in your chat app, because even when they type, they're emitting an event, so that way the other end, your computer, can respond, and you can see at the bottom, like, user is typing, even though they actually haven't sent it yet, because it's a different type of event, and then they're constantly listening for all these events. So that's WebSockets. Okay. Not getting into every protocol, but I'm going to talk about one more, just because these are the things that we use every day. The other one I'm going to talk about that's become more of a thing nowadays, because we use things like Zoom and all these like video chat apps now, is WebRTC. I'm assuming WebRTC is probably going to be going over same ports. I'm not 100% sure on that. But the way it works is that we have two people with two computers, so two clients. Two clients. Okay. And what we're trying to do is we're trying to say, hey, you know what? Video is kind of like really intensive. So if you had one server that was just receiving everybody's video and transporting it to everybody else, like that would be really like processing intensive. Like we're able to use Zoom for free. How are they able to afford all that? The reason is because oftentimes our computers are communicating directly with each other. So the way that works is that the server only introduces us to each other. So first what happens is that you're going to have a communication between these servers here, saying, hey, we'd like to communicate over, I want to communicate with this person over RTC, or through a video chat, I guess. And basically what this server does is going to collect information. I think it was like delegate, or I forget what it's called. But it's a thing. It's essentially like the address of where the other computer is. So both computers are going to say, okay, do you want to have a chat with this computer? Yes. Kind of like a matchmaker, saying, okay, hey, are you two okay with going on a date? Yep. Okay, cool. And then it gives both computers the information they need, so that way they know that, hey, we've both consented to this connection. And once they have that information, then these two computers can just speak directly to each other, because they have the information that they need, because they got it through this third-party server. So essentially, when you click on Zoom and you connect to another video, all Zoom is doing is just collecting this information from each computer, passing the information on the other computers to each one, so that way they can just establish a connection between each other. So in this case, the bandwidth is really the client's bandwidth. They're not using up further processing power from this computer here, and this allows us to do video chat. And you can see like video chat apps that are free, and you can create your own pretty easily, because again, that power is you're really just using your own computer. RTC, the server, is just handling the introduction aspects, handling just like some of the clerical aspects, so the two computers can talk to each other directly. Okay, and that's called RTC, or WebRTC. Okay, there's a lot of other types of protocols coming up, I think, like, but I mean, as far as like computers communicating with each other over the internet, these are sort of like the main things and kind of how they work. So hopefully this gives you a little bit more perspective on the internet. My name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy. And again, just like one little last point. And at the end of the day, all that matters, the programming language doesn't necessarily matter. What matters is that you have software that knows how to read these HTTP or all these little text messages that are going back and forth and decodes them. So that's why web servers, you can do them, all your backend code can be done in pretty much literally any programming language. Because what matters is the standard HTTPS, not the language that interprets a standard. So have a wonderful day. Have a great day. Make sure to head over to devnursery.com to join the Slack and Discord community, and subscribe to my YouTube channel. Thanks.